Hello and welcome back to e-sipnayan. For today's video, we are going to discuss the areas under the normal curve. For this video, hopefully at the end, you should be able to know how to solve for the area under the normal curve. We will first recall some concepts and formulas, and the most important thing to remember here is how to solve for the z-score. Z-score is a value expressed in terms of standard deviations from the means. Z-score is computed using this formula, x minus mean all over standard deviation, where x is the score, mu is the population mean, and sigma is the population standard deviation. So given any score or any value of x, we can standardize it using this formula, hence we can find on the z-table. So aside from the z-score, we are going to use another thing, which is the z-table. So z-scores can be found on the z-table, and the z-table will simply give us the summary of all the z-scores. So this is simply a table summarizing the approximate areas under the standard normal curve given in 4 decimal places. So what is the content of the z-table? The content of the z-table is simply the probability values or the so-called areas. So here we can say that the probability is the same as the area. So once you are asked to solve for a probability, it is also the same as solving for the area. Let's now have the steps to follow in computing the area or probability above, below, and between. So given a normal curve, there are 3 scenarios wherein we are going to solve for its area. First, we are going to solve for the area below, then area above, and area between. These 2 steps here are followed to be able to identify the probability or area. So let's first go to the first scenario, which is the area below. When we say area below, this is also the same as area to the left of a specific score or specific z-value. So given a normal curve, and say for example we have here x, and we want to know the area below, it means we are solving for the area to its left. That's why area below is area to the left. Please also know that the z-table also covers area or probability below. Next, area above. When we say area above, we are talking to area to the right. So again, using illustration, if we have here a normal curve and a given value of x, if we want to know the area above, then we are pertaining to the area to its right. Then lastly, if we have area between, we are talking about here an interval of 2 different z's or scores. So say for example, this is again our normal curve, and we have 2 different values of x. Hence, area between is the area that we want to know, and that is the area in between these 2 values. How do we solve for the area or probability? First, we compute for the z-score, and it's general to all cases. Then, we use the z-table to solve or really identify what is the probability or area under the curve. If it's area below, those are the only 2 steps to follow. Solve for z, round off to 2 decimal places, then use the z-table to identify the area of the z-value. If it is area above, there will be an additional step to follow, which is to subtract the area obtained from 1, or this also means that the area above is equal to 1 minus the area below. And lastly, for area between, we still follow steps 1 to 2, but this time we need 2 z's labeled as z sub 1 and z sub 2. We also need 2 areas here, and the additional step is to subtract the areas, then get its absolute value. Or in other words, when we want to solve for the area between, that is simply the absolute value of area 1 or area of z sub 1 minus the area of z sub 2. Let's now proceed to examples. Given a normal distribution with mu 75 and sigma as 8, find the area below 60. Obviously, mu is 75, sigma is 8, and this one here, or the number related to the area that we are finding, is our x or the score. So first step to solve for the area below is to solve for z, using the formula x minus mean over standard deviation. It's just a matter of plugging in the values, then calculating. So that will be 60, which is x, minus 75, the mean, all over standard deviation 8. And when we calculate that, we'll have an approximate value of negative 1.88. Again, let me reiterate that we need to round off the value of z to 2 decimal places. Now, if we have a value of negative 1.88, let's try to illustrate it here so that we'll have an idea which portion of the curve we are looking for. So remember, in a standard normal curve, in the middle, we have here a standard deviation or z of 0, 1, 2, 3 to the right, negative 1, negative 2, and negative 3 to the left. So if we plot negative 1.88, it's just a matter of approximation. And that should be in between negative 2 and negative 1, but close to negative 2. So this is the z-score. And this is the area, or the area to the left of it is what we are solving for. Now, if we want to illustrate that, we just use the basis as our marker. Then we shade the area to the left. And this is the area we are solving for. Now, since we already have the value of z, we are now going to use the z table to be able to identify the area. So again, take note of our z, that's negative 1.88. So now here on the z table, our z value identified a while ago is negative 1.88. So we are just going to use the z table to locate z equals negative 1.88. So how do we use again the z table? We first refer to the first 2 digits going downwards. So negative 1.8 is here. Then the last digit is 8, and that is our basis to go to the right. So since this is 8, and this is negative 1.8, negative 1.88 will be the area of their intersection. So basically, we need to be keen in observing here and be careful with the values we are copying. So the area of z equals negative 1.88, or the area of z is equal to 0.0301, or in terms of percent, that is 3.01%. Hence, the probability when z is negative 1.88 is 3.01. Going back to the presentation, it's also the same. So area below area below negative 1.88 is 0.0301, or in percent, that is 3.01. This area, therefore, is 3.01%. Another example for area below. This time we have mu as 60, sigma as 9, and our score is now 56. What we're going to do next is to simply plug in the values to the formula of z, then use the z table to identify the area below. So that is negative 0.44. So we are still here. The value of z is negative 0.44. So we just need to scroll down a little bit. The first 2 digits is negative 0.4. So that's our movement downward. Negative 0.4 is here. And then, to move to the right, the basis is the last digit, which is 4, which is here. So basically, we just need again to identify their intersection. Again, reminder to be very careful. Then the intersection is 0.300, or that will be in terms of percent, 33%. If we try to plot it in our curve, then the shaded area will be, if we plot negative 0.44, that will be in between 0 and negative 1. So somewhere here, perhaps. Then this will be our border line, and we are pertaining to the area to the left, or area below 56, where the z value is negative 0.44. So this is our z. Hence, this portion of the area is 33%. Next, how about area above? Again, we perform steps 1 to 2. So we are going to substitute the values. Take note that the area we are considering here is area above. given the x value as 67. So substitute 67 minus 75 all over 8, round off to 2 decimal places, but we will be given with an exact value, which is -1. If we plot it here on our z table, -1 is somewhere here. And since we want to consider the area above it, or area to the right, the area that we are going to consider would be this portion of the normal curve. So this is missing. And based on our formula a while ago, area above is simply equal to 1 minus the area below. Recall the property of a normal curve that the total is 100%. And all of the values of probabilities or areas given in the z table is always area to the left. So if I use the z table and look for the probability of z equals -1, what will be given to me instead would be the area to the left or area below. So if I use the z table and find -1 as z, the area that will be given to me will be area to the left of z. This is the area to be found on the z table. Okay, so we now proceed to the z table and find where -1 is. If z is equal to -1, obviously we just need to find -1. So scroll down. -1.0 is here. And there are no other values, so we assume that's -1.00. So the intersection will be here at 0.1587 or 15.87%. But then again, that is the area below, and this is this yellow shaded portion or region. That's 15.87%. So no matter what values you find on the z table, it will always be giving you the area to the left. Hence, to know the area to the right, what we need to do is to subtract the total from the area to the left, or subtract the area to the area to the left. So that will be 1 minus 0.1587. Therefore, the area above is 84.13%. And that is now the shaded region colored in red. So this is 84.13%. So to solve for the area above, same procedure. Solve for z. Use the z table to find the area below, then subtract it from 1. Another example, what if mean is 60, sigma is 11, and x is 77? We are still solving for the area above, so same procedure. Solve for z, round it off to 2 decimal places, then use the z table to identify what is the area below 1.55. Okay, so now it's positive, so we use the second page. Z is 1.55. The first 2 digits is 1.5, so locate, it's here. Then the last digit is 5. So here, the intersection will be found here at 0.9394. And this is the area below. So if again we want to plot it in our standard normal curve, 1.55 is in between 1 and 2, so perhaps somewhere here. Okay, and area above is area to its right. So what we have solved here, or what we have identified as an area, is area below, which is this portion, and this is 93.94%. If we want to solve for the area above, what we need to do with that value is to subtract it from 1. And if we subtract, the answer will be 6.06%. So this portion is 6.06%. Notice, class, that the area below and the area above, when you add them, it should be equal to 100% or 1. For the last case, we will be solving for area between. And for the area between, we'll be given with 2 scores. So mean is 75, standard deviation is 8. We are given with 2 scores, 52 and 78. This will be our borderlines or interval. So since there are 2 scores, let's label the first one as x sub 1, the next one as x sub 2. We are solving for area between. That's why we are going to solve for 2 z's and to find 2 different areas or probabilities. Let's first substitute for z sub 1, wherein x sub 1 is 52. Mean is 75 all over standard deviation 8. Then, the z value is negative 2.88. We now proceed to the z table, that is negative 2.88, a negative value. Let me just write here, negative 2.88. So, negative 2.8 is here. Then, 8 again is here. So, the intersection must be here at 0.0020. So, the first area below, representing the score 52 and z equals negative 2.88 is 0.0020. So we're done with the first score. For the second score, again, substitute, then round off to 2 decimal places, then use the z table to identify the area below. That's 0.38. So that is again on the second page since it is positive. 0.38, 0.3 will be the first 2 digits here. Then 8 is here. If we want to see the intersection, that will be 0.6480. So the area below, the score 78 and z 0.38 is 0.6480. And again, the formula to solve for the area between is simply the absolute value of their difference. So if we get the absolute value of the difference, we'll get 64.60%. In percent form, or in decimal, that should be 0.6460. Now, let's try to illustrate it in our normal curve. So, negative 2.88 is in between negative 3 and negative 2. So, that will be somewhere here, borderline. And then, z equals 0.38 is in between 0 to 1. So, somewhere here. That will be our other interval. The area between that we want is this portion of the curve. And based on our formula, that will simply be the difference or the absolute value of the difference between the two areas below. So here, we were able to identify that this portion is 64.60%. Last example for the different areas, or solving for areas given different scenarios. So our mean is 60, sigma is 9. Scores we're looking for is 47 and 65. So again, let this be x sub 1 and this be x sub 2. So solve for z for the first one, that is negative 1.44. So we go back to the z table. Negative 1.44 is a negative value. So again, that is z equals negative 1.44. Find negative 1.4 muna. That will be here. Then the last digit is 4. So the intersection is 0.0749. Area below, score of 47, and z sub 1 equals negative 1.44 is 0.0749. Then for z sub 2, substitute x sub 2. Then round off to 2 decimal places, that is 0.55. That's again a positive number. So we are going to find z sub 2, which is 0.55. So again, move downwards first. That would be 0.5. It's here. Then 5 is the last digit. So the intersection will be here at 0.7088. Then to solve for the area between, we're simply again to subtract them from each other, then get the absolute value. Hence, the area between is 0.6339, or in percent, that's 63.39%. So again, if you plot it in our normal curve, the first z value is negative 1.44. That's in between negative 2 and negative 1. So perhaps somewhere here, just an estimate. And then the other one is 0.55. It's in between 0 and 1. Maybe somewhere here. And then the area we are solving is the area between. And this is, based on our calculations, 63.39%. That's how you solve for area between. In summary, to solve for the different areas under the normal curve, we have 3 cases: area below, area above, and between. You first start all of this by solving for the z-score, then using the z-table to know the area below. Technically, this is the default steps in solving for the area below. For area above, repeat the same steps, but don't forget to subtract from 1. And for area between, don't forget that you're going to solve for 2 z's, identify 2 areas, and To get the area between, subtract the areas, then get its absolute value. Or it's simply the absolute value of the difference of the area.